You see it everywhere. Electric vehicles gliding down our streets. Huge green energy grids popping up. I mean, a whole revolution is underway. But behind all these massive trends, there's this hidden world of critical tech that, makes it all actually work. So, let's dive right into that.
And just look at this number, 76,000 crore rupees. That is the absolutely massive investment India is pouring into its Semicon India program. It's a huge national mission to become a global hub for designing and building the electronics that are going to power our future.
But here's the thing. With this enormous push for more power, for smaller and smaller devices, you run into a really fundamental challenge. It's basically baked into the laws of physics. How do you manage all that energy? And more specifically, how do you deal with the intense heat it generates? And how do you control the batteries that store it?
So in this explainer, we're going to break it all down for you. We'll kick things off with India's big electronics push. Then we'll look at this hidden heat problem. We'll meet what I call the battery's brain, see how it works, and then we'll connect it all back to the future of power.
Okay, first up, let's talk about the main villain of our story, heat. As our electronics get more and more powerful, guess what? They generate more heat. And this isn't just, a minor inconvenience, it's a real barrier to performance.
And seriously, that is not an exaggeration. As this quote from the electronics design firm Promwad puts it, heat is a performance limiter and a silent killer. Too much heat can throttle performance, it can slash the lifespan of your components, and it can lead to, complete failure.
So where is this enemy coming from? Honestly, everywhere. Think about the engine bay of an EV or a busy factory floor. Your electronics are dealing with crazy temperature swings, terrible airflow, and they're running under these relentless workloads, all while being crammed into tiny little boxes that just trap heat.
But we can fight back. And what's so cool here is the impact of some really smart engineering. Get this. In one case, just by swapping out a standard aluminum heatsink for a more advanced vapor chamber, they dropped the temperature of a critical component by over 15 degrees Celsius. That's literally the difference between a device that's throttling and one that's running at full power.
So, we've met the villain, heat. Now, let's meet the hero that tames not just the heat, but the raw power of batteries themselves. It's called the Battery Management System, or BMS for short.
So what is a BMS? Well, to put it simply, it's an electronic system that basically acts as the guardian of a battery pack. Its whole job is to make sure the battery operates efficiently, sure, but more importantly, safely. It protects it from damage and makes sure it has the longest life possible.
This diagram really shows you what I mean. The best way to think about a BMS is as the battery's brain and its central nervous system. It is constantly monitoring all the key vital signs, like voltages, currents, and temperature, from every single battery cell, and then it's making split-second decisions to keep the whole pack healthy and happy.
Not all battery controllers are created equal. In really simple devices, you might find something called a protection circuit module, or a PCM. But for something complex like an EV, no way. You need a full-fledged BMS. And this table shows you exactly why. A BMS gives you real-time data, advanced diagnostics, it can communicate, it's a truly intelligent system.
Okay, so we've established that a BMS is the brain. But how exactly does it think? Let's break down the specific functions that give it this incredible power of control.
A BMS is a master multitasker. It's juggling protection, performance monitoring, diagnostics, communication, the whole shebang. But one of its most important, and honestly, one of its cleverest tricks, is a process called cell balancing.
Here's why this is so important. A big battery pack is actually made of tons of smaller individual cells all strung together. Now, if these cells get out of sync, with some more charge than others, it can lead to some cells getting overcharged or overdrained. And that's not just inefficient, it can be incredibly dangerous and lead to, catastrophic failure.
And this is what cell balancing does. It's kind of like a conductor making sure the entire orchestra is perfectly in tune. As you can see here, the BMS works to equalize the charge across all the cells, bringing them all to the same level. This doesn't just maximize the battery's total capacity, it dramatically extends its life.
Now, there are two main ways it does this. The first is called passive balancing. It's pretty simple. It just burns off the excess energy from the most charged cells as tiny amounts of heat. The other way is active balancing, which is way more advanced. It physically transfers energy from the fullest cells to the emptiest ones. It's more efficient, for sure, but also way more complex. Right now in India, passive balancing is still the more common method.
All right, let's zoom back out.
We've been deep in the weeds with the micro-level challenges of heat and battery control. So how does all this connect back to India's macro-level ambition to become an electronics superpower? Well, here's the reality check. This chart shows where India is getting its battery management systems. A huge 46% are either assembled from imported parts or developed in-house. But look at this, a big chunk, 21%, are imported directly, and most of those come from China. This really highlights a critical dependency.
And that right there brings us to the core issue. For that 76,000 crore rupee investment to really truly pay off, India can't just be a place that assembles products. It needs to master and manufacture these critical, high-value components. Things like advanced thermal solutions and intelligent battery management systems. That is the real path to self-reliance and true innovation.
So as we move forward, you have to realize that the ultimate challenge isn't just about generating more power. It's about having the intelligence to control that power. The countries and the companies that master this control, they're the ones who are going to lead the electronics revolution of the 21st century. The only question is, who will it be?